Electrolysis or electroplating. Today I'll be performing copper plating at home. If you want to do this, you will need copper, root kill, a 6-volt battery, alligator clips, distilled water, a conductive graphite paint, and I'm using a mummified frog. Copper sulfate is toxic to the touch and contact should be avoided. Proper PPE should always be worn during this experiment. I'm not wearing gloves or goggles. Do not do what I'm doing. By layering the frog with conductive graphite paint, I was able to use the frog as the cathode in the electrolytic solution. My first couple of coats of graphite paint went on smoothly and I wrapped copper wire to the frog in order to get the best possible connection. Here I am painting graphite over copper wire to better conduct the electricity flowing from the battery to the frog. As the frog is waiting to dry, I prepare my electrolytic cell by weighing 100 grams of copper sulfate. This is mixed with 2 cups of warm distilled water. I use copper wire that I kind of just twist up as the anode in the electrolytic cell. Then I connect this to the positive terminal of the 6-volt battery using alligator clips. I use a copper wire to make a connection from the copper wire wrapped around the frog to the other alligator clip, which I then connect to the negative terminal of the 6-volt, at which the electrolysis starts to begin. By minute 30, the frog is almost completely covered with a thin layer of copper. After 6 hours, over 10 grams of copper was deposited onto the conductive graphite surface of the frog. Electroplating is the process of creating a metal coating on a conductive surface using an electrical current. To plate the frog, we first need a solution of copper ions. The root killer dissolves into water and creates a conductive solution of positive copper ions and negative sulfate ions. Electrons travel from the negative terminal in the battery through the metal nail cathode and into the solution. From there, they travel through the conductive solution towards and into the copper anode and back into the positive terminal of the battery. Electrons build up in the nail cathode, and the nail becomes negatively charged and attracts positive copper ions. Ions from the aqueous solution. Copper from the copper wire then replenishes the electrolytic cell with more copper ions as the nail takes copper ions out of solution. As you leave the nail in solution in the current, more material is transferred through the solution. For every 1 copper ion that is deionized, 2 electrons are required. Knowing this, for every mole of copper that is copper plated, 2 moles of electron are required. If we know how many grams of copper was plated, we know the charge that was required to do the process over the course of the time. And if we know how long the process took, we can determine charge over time, or amps, of the battery used. given 1 mole of electron has a charge of 9,600 coulombs, and 1 coulomb is 1 amp times 1 second.